Hi, this is Len from Coffee Roasters Club, and today we're doing a big project. We're going to be roasting coffee beans using syngas, S-Y-N-G-A-S, which is produced from this wood gasifier that I made over the past, started as an idea about 5 years ago, and it finally has come to fruition. This is our first application of the gas that is produced by wood chips in this case, and we're going to be roasting coffee beans, actually 5 pounds of coffee beans, using the wood gas produced. It's going to be a long video. It's going to be a detailed video. If you want to jump ahead through YouTube to look at bits and pieces of what's going on. If you want to watch it straight through, feel free. It'll probably be about 30 minutes long, if not more. So I'm going to start by explaining each part of the gasifier. Then we'll get the gasifier running. We'll get to produce gas, and we'll start the burner, and then we'll put the coffee beans over the burner and we'll let it roast. Let's start. Right here is the reactor chamber. It's a 55-gallon drum, and inside this 55-gallon drum, through the center, is a stainless steel tube, stainless steel cylinder with a grate that's on the bottom. The cylinder is attached to the lid here, beneath the hopper that you see right here. The hopper is basically a galvanized garbage can with sight glasses I made in it, so I can see the level of the wood chips inside. And you can see, I'll pop this open a little, these full wood chips. I just made these wood chips myself with our chipper. We had a lot of branches that came down during Hurricane Irene in Connecticut, so that thing is full. I had the sight glasses to tell me from a distance, without having to open the lid, what level of product I have in here to turn into gas. So right now it's just a little bit of, it's between 3/4 and full. Getting back to that, the tube. The tube goes from the top of the 55-gallon drum all the way down to about the level of this sight glass. I can look through here and see the fire when it starts inside, actually the gasification process. At the very bottom of that tube, again, is a grate that has 1/2-inch holes all over it. Also on that grate are igniters that I use to ignite the wood chips to start the gasification process. Now, part of this whole process here needs to be shaken every now and then, the tube, at the grate part, to make sure that the ashes don't clog up the bottom of that grate. Also, what is important is that the product continually go down the tube as needed. Usually this is accomplished by somebody shaking or mixing the product in the wood chips in the hopper, and also with some kind of a little shaker mechanism that they attach to the basket. I decided to go another route. I experimented with an industrial vibrator, which is attached to the 55-gallon drum, and it works great. Basically, I have it set up on a timer, and there's the timer. You can see a cycle time and an interval gap. I have it set so that every 5 minutes, once the gasifier is in operation, the industrial vibrator will turn on for about 10 seconds. And what that accomplishes is it sends out a low frequency, very strong vibration. It shakes the bottom of that shaker tube I told you about. The end of it is at the grate on the bottom. It loosens up any ashes that may be accumulated in it. Also allows the product, the wood chips here, to continually go down the tube without any encumbrances. The encumbrances being a situation called bridging. And bridging can occur when the product kind of gets jammed in the tube, and that's not good. If that happens, air pockets form inside the cylinder that goes down the center of the tube, and gasification process can be interrupted. A fire can occur because of the air pocket. So the industrial vibrator, vibrates all that stuff and it keeps it flowing down good. This type of wood gasification process is called a stratified downdraft gasifier. And it's called that because what we have is, at the very end of this, we have a vacuum system. This is an industrial vacuum that I bought off of eBay for probably about 35 bucks. This supplies a vacuum. And the vacuum, here's some coils, and I'll explain that a little bit later. There's the cyclone. The vacuum pulls the atmosphere out of the gasifier through this tube. Okay, so what happens is the vacuum turns on, air goes into here, in through the top, goes down through the mixture, goes down through that center tube, and at the very bottom gets processed through the charcoal and the very hot mixture that is burning at the bottom of the gasifier tube. The process creates thermochemical reaction, and what is the end result being a burnable gas that is composed of hydrogen, ethane, methane, carbon monoxide, which is combustible, believe it or not, and poisonous. Also water vapor is created, and some carbon dioxide. Now, say we turn it on, you have the gases now flowing from the gasifier through that outlet. It goes into a type of cyclone system, a cyclone separation system. This cyclone separation system separates water from the mixture. Water vapors accumulate, go down into the bucket. Any kind of heavier particles that may be involved in this mixture that's coming out, the cyclone takes care of that too. Dumps it in the bucket. Goes from this cyclone to some cooling tubes. As you can see, this is all stainless steel. Stainless steel bendable cooling tubes that I've sealed a little bit around the bendable parts, the little corrugations, to make sure that there's no air leaks going through. Cools off the vapors there. Then it goes underneath this cooling tower. You can see the tube there. It goes up underneath. It goes right up this stainless steel tube. And again, out of the vacuum. Then it goes from the vacuum in the beginning, and when I turn it on, it goes from the vacuum, and I have it pumped out. The gas goes pumped out into the backyard through this hose until I get to the point where I feel confident that it's producing good gas to burn. When it starts producing good gas to burn, I turn off this valve, and I turn on this valve. This valve then goes to a swirl burner. This is the swirl burner right here. The swirl burner is basically made out of 100% stainless steel. Inside the swirl burner I have a thermocouple probe, and I have a gas igniter, and there's the outlet that you can see at an angle. It produces a swirl, and that's where the mixture burns. Now this is thermocouple controlled, PID controlled. You can see the wires that go back to the system, and here is the main control system. You may have recognized part of the system being the vibrator control right there. Now we have a two-part system right here. Two PID functions. The bottom one is the main igniter set for, and that is connected to the reactor chamber. What I do is when I first turn this on, I have this set so that the igniters stay on until there's an internal temperature in the combustion rate of 400 degrees. Once it hits 400 degrees, the igniters turn off, but I can still see the temperature rise. The temperature inside this thing will get up to over 1300 degrees Fahrenheit. Once it gets over about 1200 degrees Fahrenheit, I'll turn on the swirl burner. The swirl burner is also PID controlled. I have that set so that the heating element inside, actually the igniter inside the swirl burner, turns on and stays on until it recognizes a temperature of 400 degrees also. Now, it's going to sense that by the flames that are going to be, you know, shooting out here. I don't know if you'll be able to see it that good during the daytime. The flames are generally very blue because it's mostly hydrogen burning. But this thermocouple probe right here will get very hot, and so it'll turn off the igniter once it gets over 400 degrees. Now let's say for some instance that the swirl burner stopped because maybe the gas mixture got poor for some reason. That thermocouple is going to notice that pretty fast, and it'll try igniting it again. So it'll turn on that heating element again. Not the heating element, excuse me, the igniter, until it lights again. That is basically the process right now for this particular application, but this is not where this gasifier application ends. I have a generator right here that will be connected to the gasifier in the very near future, and that's what this end port right here is for. The process will be the same as in starting it, but when I get up to the point where I get burnable syngas, at that point I will turn off that outlet that goes to the backyard, and I'll turn on the outlet that goes to the generator right here. At that point I'll also turn off the vacuum system. Here's a variable control for the vacuum system, which is used used all the time for the swirl burner, but only for starting the gasifier for the generator. So I'll turn off that fan, the vacuum, excuse me, and then I'll try to start up the generator using the syngas. What happens is the generator itself, being you know, pistons and everything involved, is a vacuum in itself, which means that it'll continue to pull the gases out of the syngas generator, the gasifier, and I'll be able to produce electricity using just wood chips or other junk like shredded cardboard, you name it, and anything organic and burnable, this thing will produce gas with. Okay, and what I'm going to do now is I'm going to walk over here and I'm going to set up this coffee roaster drum on a special holder I made over the weekend. There's a 60 RPM motor system on it. I have it cooled with a fan system. This is going to be the first time I ever used this, so anything can happen. It's going to hold the drum with this kind of the drum is going to be hooked right into there. It's going to be hooked over into that Lovejoy connector. There's not going to be any rubber spiders involved. They definitely would melt. So I had this connected directly into the metal of the drum. Let me show you the drum. I've had this drum. I made this drum about 6 years ago. I've never used it. It was for a special project. You know, we all have our special projects we try getting off the ground. Well, this got as far as making the drum. This drum actually holds 10 pounds of beans. And it's a special drum I made for a special project that was going to be an electrical coffee roaster. But it's just been sitting around for 6 years. I decided I'm going to try an open air coffee roast with it. Thing is, like this, right now I'm only going to be roasting 5 pounds of beans in it. This apparatus I made in the motor can only hold 5 pounds of beans. It can only really rotate 5 pounds of beans. If I had a stronger motor and maybe a little bit heavier setup right here instead of the setup I have, maybe with structurally more sound, then I would feel more confident roasting 10 pounds of beans in it, because it definitely would hold 10 pounds of beans. So what I'm going to do now, I'm going to pass this camera off to my wife, Cara. She's going to tape it from here while I fill this drum up with 5 pounds of beans. Okay? Come on, hold it. Go. Okay. You got it?
Yeah.
Okay. Here's the drum. Let me show you right here. This is where it's going to connect into the Lovejoy connector. That's right there in the end of this right there. It's going to hook right into there. These are handles I have. I'm going to wear heat-proof mitts when I take this off the burner. But right now I'm going to fill it up with 5 pounds of beans. I'm just going to open this up. Flap open this right here. Kind of situate it on this table so I can put 5 pounds of beans in it. I got a 5-pound bean mixture here. It's an assortment of. I got Indian Monsoon Malabar and a bunch of other beans in here. What's that called? Whoop! 5 pounds right there. Flap this down. I'm going to connect it so that it doesn't open while roasting. Bowls. I'm going to put them right there. I'm going to attempt to do this myself. See how that goes. Alright, now I just get this. You see? There's a little, I have a bronze flange, a bronze bearing right there. Pull this back. Put that rod right in there, just like that. I'm right over here. And I'm going to insert that like that. Yeah. Okay, now I can grab the camera again. The car. And there it is, all set up. Now, you can see that's how it connects right into there. And a spring that provides the tension. This right here, apparatus, I'm going to pick this whole thing up and I'm going to place it over the swirl burner when the swirl burner is in operation. So it's going to roast over this very hot flame at 60 RPM. Now basically I have the switch right here I'm going to turn on. I got to give it a little push to get it going, and there you go. So right now I'm going to make sure that that's on the table good. Remove these bowls right here. I'm going to put them down. Alright, there. Now, backing up a little bit. Right here is a coffee bean cooler that will hold basically over 10 pounds of coffee beans, but we're roasting 5. It's a big stainless steel bowl on top of a special metal bucket I produced, worked with. Bless you.
Thank you.
Hooked up to a 3 or 4 horsepower vacuum. Okay, so I'm going to walk over here now. And we're going to attempt to start this. First thing I do is I make sure that this is on. It's on. Okay, now I'm going to go over here. I'm going to turn on the igniter. Oh, first, whoops, back up. Okay, I used this maybe a few days ago, so it might have gases in it. So before I try to ignite anything, let me first make sure that there's no gases inside there. I'm going to do that by turning on the vacuum system to pull out any gases. What I did was I opened up the valve that goes to the out, that goes out. Okay, so it's just blowing gas right. Anything that's in that chamber is getting blown out into the yard right now. That should be good. I'm going to turn that off now. Now, since I did use this a couple days ago, I want to make sure there's no ashes or anything that are jamming up the bottom of that grate that I was talking about in the inside of that gasifier. So what I'm going to turn on the industrial vibrator a couple times to make sure. You'll hear a noise. You also hear some noise of people working around the, neighbors working on their yard. Alright, did it once. I can just turn it off and do it again. It does it automatically. You notice a little bit of rubber I have on the bottom. I have a piece of, it's not rubber, it's actually high temperature silicone padding I use as an anti-vibration for the very bottom of this. Otherwise it'll make a racket on top of that concrete. Underneath the concrete I have fireboard too. So this whole thing is on top of fireproof stuff. Okay. Now we're going to go over here and I'm going to turn on the igniter. Set to turn off at 400. It's 64 degrees inside there right now. Hopefully you can see that well. Okay. Let that sit for a couple moments. Go down in here. Can't really see it yet. Shortly you will. Let's see. I can see a little bit of it. Whoops. I usually let it sit for a bit so I can see the temperature increasing a little. Appears that there's some is glowing a bit in there. Let's go over to the other side. Yep, temperature increased by a degree. Which isn't a heck of a lot, but in the very beginning, it may take a tiny bit until it really starts glowing. Then I turn on the fan to really get it cooking. Good, this appears to be increasing a bit in temp. It's up to 66 degrees. Can't see it too well, but there's 67. When it hits 80 degrees, I'll feel confident on maybe before that. Well, we'll say when it hits 75 degrees, I'll feel confident about turning on the vacuum system to get the gasification system really ignited, and the temperature goes up pretty fast. It's at 70. 71, 2, 73, 74, 5, 6, 80 degrees. I'm going to turn on. Okay, I'm going to turn on the vacuum system here now. There. So that's full. So it's 84 now. Temperature does increase rapidly up to 90. Like I said, this video is going to be a longer video, so feel free to jump ahead to bits and pieces, or again, if you want to look through the whole thing to see the whole process, it should be very interesting. I wanted to do this yesterday, but it was raining like crazy in Connecticut. It's okay, it's up to 114, 117. I'll go over to the outlet out in the backyard here. I don't think you can see anything yet coming out of it. There's the outlet. Nothing yet. Last time we tried this, I had some other anti-vibration feet underneath the reactor, and they actually melted. They melted totally. So I had to put the higher temp ones on there. I really didn't think it was going to happen, but it did. I'm going to turn on the vibrator now. For whatever reason, the temperature went down a little bit. It happens in the beginning. You know, it's not a perfect technology. It has a little bit of a background. You know, I'm going to try to fill this in with my talking, so I hope I don't ramble on too much. But this was used extensively during World War II in Germany. They actually fitted gasifiers to their cars, and the producer gas, or syngas, is used for the operation of the car, because the Germans were using the fuel for their war effort. FEMA, which is a division of, you know, emergency and control in the United States. No, we got, yeah, it's starting to climb pretty fast right now. It must have good ignition. It's up to 226, it's rising rapidly. FEMA actually has instructions on how to produce gasifiers for farmers' tractors, so during a national emergency we can still have crops tended to. Temperature now is at 300, and as you can see, it climbed up pretty fast all of a sudden. It's at 300, it's at 400. Okay, let you know, the igniters have now turned off inside the gasifier, and the temperature inside the gasifier now is 555, 60. It's going up pretty fast. 600 and some odd degrees. Right now, there's probably smoke coming out of that. Yep. Or gases, syngas. Actually, you can't see it too much. But it's going out of there. The hose is warmish. Going on in the backyard. Now, when this gets up to 1,000, it's already at 900. Back this off a little bit, you can see it. 900, and when it gets up to 1,200 degrees, 1,200 degrees Fahrenheit, I'm going to turn off the vacuum. I'm going to back the vacuum down to about a little bit over half speed instead of full speed. In fact, I'm going to do it right now. All I do is go over here, variable rate. I have it now at a little bit over half, which I found, see, I found is the best for you know, the gasification for my purposes here of roasting. And I mean, I can have it cranked up if the thing gets so hot. I mean, it'll get up to over it'll get about 1,800 degrees Fahrenheit. Right now, I do a close-up here for you. 1,336 degrees. I'm going to let this stabilize out for just a little bit. At the very beginning, there's quite a bit of water vapor that is produced. And of course, water vapor mixed with the gases just doesn't allow it to light properly. I want it to light properly, of course, and have it stabilize a tiny bit. We're looking at basically stabilize at about, it'll fluctuate during the operation from like 1,200 to 1,500, but right now, like it wants to sit at around 1,364 degrees. Remember, that's at the very bottom inside this reactor chamber. That's the temperature at the very bottom of the reactor grate, where I have a thermocouple and igniters. Okay, so that's the temperature right at that point. At the very end, the gases are cooled down considerably. I mean, to the point where it's not affecting the structural integrity of the PVC pipe that you see coming out. I doubt, I'll give it about 2 more minutes of operation, and then I'll go ahead and I'll try lighting it. just to make sure that the gases are working properly. The gas is being produced properly. The tube is definitely getting warmer. I think I'll turn this on a little bit. Here's the swirl burner. I'm going to open it up a little bit, see what happens. You can see a little bit coming out there. I'm going to turn off the back. You can see now. Let me keep this lit. Go over here. And again, this is the switch that'll light that sucker. See if it lights. It lit. Hear that puff? It lit. It's already 200. You can see. There, it's already over 400. It stopped the igniter, but the interior of the gasifier is at where are we here? 1300 degrees. Look at that. It's already 1,000 degrees inside that swirl burner. At night, if you were to see this, and you can't see the flames that well right now, but believe me, I mean, right now it's at almost 1,200 degrees Fahrenheit inside there. I'll let this kind of do its thing for just a little bit, just to make sure the gases are stable, and it appears that they're pretty good. It's at 1,300. Look at that. It's hotter in there now than the gasifier. 1,326 degrees and climbing. Now, note, this is only half. I have this operating at half speed right now. If I put that at full speed, that sucker would get over 2,000 degrees inside the swirl burner easily. That's working good. Okay, I'm going to give the camera in the car now, and she's going to show me. And we're going to start roasting. I hope.
Your gloves
Put
on.
on my safety glasses. Can you see everything?
Yeah.
Pick this up. There I go.
Try not to light yourself on fire.
Try not to light myself on fire. My car is set. Wait, over that.
There you go.
There you go. Turn it on. Give it a good spin.
Oh.
There we go. That's crazy stuff.
The Wheel of Fortune.
I hope this thing doesn't fall apart. Sorry. We're roasting beans now, open air. Over flames, over a heat source that is about 1,400 degrees Fahrenheit. You ever see such a setup? Probably not. I don't think I ever have. I wonder if this has ever been attempted before. I'm going to back up a little, car. What? Yeah. No, I mean, I tried to make this as good as I could with parts that are hanging around the house. It's pretty wild shit, right? Pretty wild stuff right here. I think I heard a swear word. Whoops, sorry. That is pretty wild. Get up a little closer, man. You can see the flames, maybe. That's not smoke you're seeing, folks. That's hydrogen burning. Hydrogen and ethane, and maybe methane. Now, I feel safe in roasting this over the syngas because I know that I'm burning wood chips. You know, wood chips is the gasification medium. Now, if I was using cardboard or something, I wouldn't feel safe in roasting a food product over that. I don't know what kind of other gases or residues may be involved from glues used in the manufacture of cardboard. But there's plenty of wood around, as you can see. We live in not a lot of property, but plenty of tree limbs that I can always chop up. You can see chaff flying around. Again, this is the first time that I have ever done anything with open air roasting like this. This is the first time for me. I have no idea what the results are going to be like. I usually use this big barbecue grill I have. That big barbecue grill, you know, is where I do most of all my roasting usually. But this is something real new. Right now, the temperature inside that gasifier, the Swirl burner, is 1,340 degrees Fahrenheit. Inside the actual gasifier, it's 1,164 degrees. So it's dropping a little. That sometimes happens, and usually it kicks up again. You know, I'm keeping my eye on that. It's still getting good flames coming out there, so it's still producing gas. This happened last time for a little bit. It went down, you know, it's down to 1,151. And then it got down to below 400, and then it kicked on again after the igniter's lit. So I don't know. I hope that's not going to be the case again. Fan system's working fine. It's producing enough syngas. I'm going to go over here. I don't see any leaks anywhere. Okay, it seems to stabilize it. Well, still dropping a tiny bit in the generator. Gas temp itself, remember this is a big experiment. Gas temp itself, where are we here? That's gone down to 1,230. What I'm going to do is I'm going to turn up the velocity a little bit inside that Swirl burner. See if that has an effect. Still operating. Nothing's falling apart yet. Okay, the gases are now increasing in temperature. Yeah, a little bit. Seems to be going okay now. Seems to be increasing a little bit in temp. Yep, it's up to 1,140 now inside the gasifier, so it seems to be increasing in temp. Which in correlation, when that increases in temp, the gases are produced better, and of course, gas is now up. The swirl burner is now registering 1,291, 92. The industrial vibrator just kicked on, so that'll maybe even increase the temperature even more. Yeah, it's increasing quite a bit now. It's at 1,300 degrees. We got it cooking really good again. It's all automatic. I'm trying to take care of the automation of this. Is generally something you have to continually fool around with non-stop, and I'd rather not have to deal with that. Alright. Remember, I'm roasting 5 pounds of beans. I don't know how long it's going to take. This is a bizarre thing here that we're doing. Maybe I can increase the temperature just a little bit there, even more. Yeah. I turned it up, it's about 3/4 of the way up now. The vacuum. Let me see if that has an effect on anything. A little bit windy out. I'm going to turn up to full speed. I can feel the heat from here. We're almost up to 1,400 degrees inside the swirl burner. At 1,354 degrees. Still wants to stay down at about 1,170, which is a little bit below. I changed the silicone feet. I changed the silicone feet right here. Maybe the vibration is not as intense as it was when it was laying against solid concrete. Maybe it's not shaking down as much as I really wanted it to. I can smell coffee beans roasting now. Well, that's a good sign. I don't know what kind of temperature reading I can get infrared. I got my infrared thermometer here. I don't know how accurate that is. It says like 300 degrees inside the bean chamber. I don't know, I'm fluctuating quite a bit. I don't know what I'm reading. Let's see if I get closer. See, that's like way over. I mean, it's going red hot. You see how hot that is? That's red hot. That's really hot in here, man. All right, we're getting up to actually at 1,200 degrees inside the reactor. I like that. That's good. And climbing. Excellent. And climbing. Good. There's a mix. This is a long video. Again, I apologize. I'm going to run out of battery. Alright, I got plenty of battery left, and I got plenty of minutes left, so it's already been 45 minutes. Wow. You guys have patience. Thank you. (1,242 degrees) and climbing inside the reactor. 1,318 inside the swirl burner. Not any longer than it should be, but like I said, it's all an experiment. Here's the electric cord that goes. Oh, what happened? The motor turned off? That's not good. Well, looks like we have an issue here. Car, you want to grab the camera? What, the motor thermocouple kick off?
It looks okay.
The motor might have overheated. There we go. Come on. Stop being a bugger. Come on. Why are you doing that? I gotta turn the heat down a little. That's strange. It's turned off now. Darn it. Well, these are the things that happen, folks, when you're doing experiments. Try it again. I don't think they get roasted that good. Oh, come on.
Too hot for a motor.
Woo! The heat coming off that. 1,400 degrees in there now. Doesn't want to work. Looks like we have an issue, folks. Definite issue. Let's turn it by hand like this for a little bit. Maybe the until it cools down, the motor. Maybe the thermal switch cut off in the motor. This tells me that I need a stronger motor. I hope I didn't burn out the motor. Let's see what I can do here. I have a feeling I gotta get this closer. This is one thing I gotta do. I gotta bring this level down. About, what do you think, about 3 inches?
Yeah.
2 inches? That's one thing I gotta do, and I gotta build a more powerful motor. It's all part of the experimentation process. Come on. Nope, doesn't want to go yet. Let's see, what can I do? I know I can do. See if it's too much, right?
What are you doing?
Yeah, that'll be too high. Shit. Hold on. Well, the beans are starting to roast. I can't lift that up any higher. The beans are definitely starting to roast. Ooh, that's hot. 1,400 degrees going in there. I thought I could put this underneath it, but that's not going to do it. This is good. Bend. Oh, there, touch it. See?
Don't try this at home.
Yeah, don't try it at home.
Oh God.
Watch it. You hear the beans cracking now. It's not by design.
Plenty of smoke.
Yeah, I got it. Yeah.
He's burning some of them there.
Yeah, for sure. Alright, come on. I wanted to have it done, but see, certain adjustments have to be made here and there. Come on, work. Damn you, motor. Damn you, motor. Bugger. That motor must be fried. That's too bad. That means I gotta make a heavier duty setup. But this is a neat idea. I wouldn't be doing it if I didn't have my off gloves. Well, you can see it's producing good gas, that's for damn sure. Darn it. Man, I wish that worked. Gloves on, it's hot. This is what we call cookie. Some of the beans won't burn, of course. Gloves are getting so freaking hot. It sucks. Anyhow. Come on. I need coffee beans to drink. So it's hot enough in there. Where's that smoke coming from?
Burn your beans. They're crackling.
Oh, they're crackling.
Oh, honey.
What happened?
You lost your spring.
I lost the spring. That's great. Ah! You got another spring on there. Woo! That's hot.
What?
What's burning?
How am I supposed to know? Everything? I can't tell.
What?
I can't tell what's smoking. Everything is smoking.
Turn down the velocity of that fan, man.
way too fucking high. I turned it back down. You can hear the couple of close. If people can hear it, look at too close. Might melt the camera.
It is 1400 degrees. We got silicone rubber underneath the is melting underneath the gasifier. Show 'em. Starting to. Well, maybe it's cooled down.
It's cooling down already.
All right. Learning a lot from this. Learning that I gotta get it closer to the heat source. Number one, because it's open air drum. Number two, I gotta get a better motor and structural support for this sucker. We'll be in business. Right now it's too wobbly. I gotta get better spring. Do your deal. I gotta turn that back up. This thing can way too long in the roast, of course. Everybody that's watching this knows that. If you're a coffee roaster. Hey, you hear the louder vibration now because the silicone is melting underneath it. That's okay. We need that vibration to work. It's actually more effective, I think, when it has a little bit more of that vibration. Definitely, it's already over 1300 degrees inside that sucker now. See that? That's good. We're getting there, people. I'm not giving up on this roast because I gotta drink this. I'm sure it'll be okay. Like I said, I gotta work on it. I gotta drop this drum down about, even with the bricks underneath that. I don't want bricks on there. I got to cut these legs down about 4 inches. I gotta tell you one thing, the gasifier is working nice. I'm gonna do it seems to work best by hand. I'm gonna do a slow turn like this. You know, maybe it needs that. Maybe it just needs a slow turn. Maybe a slower RPM. In fact, that's what I'm going to do. I'm going to do a slower RPM, higher torque motor. Rotate it slower. Because it's the open air thing. If it was enclosed, it'd be a different story. I think they're cooling down too much. Yep. Beans are starting to smoke in there. I mean, this is way longer than it should be. It is like it's 1,500 degrees Fahrenheit. 1,500 degrees Fahrenheit inside that swirl burner now. The probe is glowing red. Show them the probe. I mean, it is hot.
Is that second crack?
I don't know.
Who knows?
Partially.
Some of
I
them.
can tell by the color of the beans, they're not the way I want them like that. I'm doing it by. Some of them are at. No, it's roasting unevenly. And that's because of the way I'm turning it here. Obviously, they're just sitting in contact with the flame, and then I determine they're not. Some of the beans are sticking. It'll be an interesting bean mix. The gas fire itself is at a nice temp, 1,249. The actual, you can hear a crackling now. This is the first crack. I mean, there's some beans that probably have hit second, but I'm pretty sure we're at first crack here for the bean mass. Wind's picked up. Of course, that affects things. That's first crack. Definitely got to get that heat source closer because, you know, as it gets more windy out, of course the temperature's going down. Sure different, man. Most people don't roast 5 pounds of beans at a time. Old fast, you know? Wow, what's that up to in there?
Hot. I'm just judging by the color. I mean, we've heard cracks and stuff, but it's been uneven. Hot. Damn it, I wish I had somebody. Do I? Around here, do you see anything? Well, where's your pliers? Would that help you? Got pliers?
Oh, I thought you had a bean fire. Yeah, we do. A little bit. Yay! I'm tired of holding on to that.
Whoa!
Bean fire! Alright, we're gonna turn that off now.
I guess.
Yeah, we got a bean fire,
Oh,
folks.
those are ruined.
Those are ruined. Car, go inside and get some water real fast. Water. All the extra out. Wow. Car, come here. I got it off. I got it so it turned off. Let's get them out of there. Get your gloves on. Gloves on. Get your gloves on fast.
What am I doing?
It's okay. Just get your gloves on. Where's the camera?
I had to drop it.
Is it still working?
I think so.
All right. Woo. Well, we got some burning beans. Okay. I'm gonna put this right here. Maybe you can see it.
That's the bean fire, folks. Okay. You want to grab, pull that back. Pull that side back. All right. Got it?
Yeah.
Oh, that's hot. Ah, come on. There we go. Oh, God. That's what we call Spanish roast. Well, actually, God. You want to stir 'em? Ah. Well. That was something that you don't ever want to do at home. Well, I put the, we didn't need to throw any water on it. Turned off the swirl burner by basically turning off the vacuum. Turned off the outlet right there to the swirl burner. The outlet going to the backyard's off. Closing up the gasifier entirely. It's going to smoke a little until it just dies by asphyxiation. Temperature's dropping pretty rapidly, I guess, inside the gasifier. 1400 degrees still. I have all the outlets closed. Again, swirl burner's off. Here are the beans. Nice mottled look. A lot of them are. I think I'll drink it. I don't know how it's gonna be. It's gonna be definitely well, we say a Spanish roast. Looks like a lot of the beans are at full city plus and Spanish roast. This is about the darkest you can get. Well, it was on fire, of course, as you saw. And that was because of the motor being shot. I don't think it'll turn on now. Motor's shot. So we gotta put a stronger motor on there. A little bit lower RPM. Maybe the same RPM, but it needs to be closer to the burner. Everything cured well for the gasifier. I have temperature gauges on the outside of the gasifier. This is the environmental temperature inside of it, not at the reactor plate. Right at this level, it's at 300 degrees. Right down outside of the reactor level, it's 350. I saw it before it get up to almost 500 there. You guys, I didn't say anything about it. So, I'm gonna make this a little bit tighter. My wife Cara is stirring up the beans that I'll be drinking in the future. That is called an uneven mix. Uneven roast. But they're cool. Yeah, they're cool now. I put my hands right in it.
They're on fire.
They were on fire just a moment ago. Okay, well, hey. There's the gasification application. That's our first application of using a wood gas. Okay, that's our first. We turned off the first application using the wood gas, and I won't say that it was a complete disaster. I mean, we figured out the weaknesses in the system, which is basically what this has been all about. What we've been doing for quite some time now. So we know what where the weaknesses are in roasting coffee over the swirl burner. We need a stronger motor, maybe a little bit less RPM, has to be closer to the burner. The reactor itself is working fine. The ignition system for the swirl burner worked perfect. It's cooling down fine, and that's about it. Thanks for joining us. It's been a long video. Let's say 35 minutes. I thought it was more than 35 minutes.
Yeah, I thought so too.
Why does it say 35 minutes?
I don't know.
That's strange. Anyhow, we'll talk to you later. Bye. Why would it say that?
I hope it's okay, because I know it